So this is just a little follow-up to our work on Venn diagrams and independent events and using the general addition rule. So here's a question. Use the general addition rule to calculate the union of A and B, given that they're independent. Remember that independent means B occurring has no effect on the probability that A occurs, meaning one event can occur, the second event has the same chance of occurring. Like flipping a coin twice. Flipping heads the first time has no outcome on the second. So what that means is that the events can't be mutually exclusive. Because mutually exclusive, if one event happens, the other event's probability changes to 0. So mutually exclusive events are never independent, because if one happens, the other's probability of happening goes to 0. Independence means if one event happens, the other has the same likelihood of occurring. So that's important to know here. So because these are independent, just like for two coin flips, what's the probability of getting heads heads? You would take 0.5 or 50% and multiply it by 0.5 and get 0.25 or 1 out of 4. So 1/2 times 1/2 equals 1/4. So that's the multiplication rule for independent events. So A and B occurring would be 0.2 times 0.4. Let's look at visualizing this in our sample space. So I'm going to make a rectangle like this. Inside the rectangle represents all possible outcomes, the entire sample space. So all the probabilities in here should add to 1 or 100%. Since these two events are not mutually exclusive, they're independent, they can have an intersection. This is our intersection right here, the part that indicates that both events occur. Again, because they're independent, we can just multiply 0.2 by 0.4 to get 0.08 as the chance, the intersection, the probability that both events occur. So there we've added 0.08. Now keep in mind this whole circle, A, is 0.2 or 20% of the time. So if this portion of the circle is 0.08, X represents the probability that A occurs and B does not. So this value X plus 0.08 have to add to 0.2, so X must be 0.12. In the same way over here, circle B has to add up to 0.4 for the probability. And we know the intersection is 0.08. So this value plus 0.08 have to equal 0.4. So this must be 0.32. We have all of those values filled in. So we know the probability that either occurs will be 0.12 plus 0.08 plus 0.32, or 0.52. That's called the union of the two events, the U looking symbol. Now we know the whole rectangle is equal to 1. So what's the probability that neither occurs? Well, A not occurring is called the complement of A, and where that intersects B not occurring is this whole area out here, complement of B. And because we know they add up to 1, we can subtract 0.52 from 1 to find that this area must be 0.48. Now what that shows us is what we just walked through is the general addition rule, and you're given this rule here on your formula sheet, that the union of the two events for independent events, you add the two events and subtract their intersection. For mutually exclusive events, you could imagine this applying as well because their intersection is 0. So you just add the two events occurring. Here, these events aren't mutually exclusive, but that's what this general addition rule is showing you, what we just walked through. If I just added 0.2 to 0.4, I'd be counting this area, the intersection, twice. So I'd get 0.6 as my answer, but this area where they both occur just got counted twice. So what we do is we add them, and then we subtract the intersection since it got counted twice, and we get the correct answer there. Now, this formula is if you're given the probabilities. If you're given the Venn diagram, obviously we don't want to subtract the intersection because we're adding them up separately, and we only added this once. So we'll see a quiz question like this. We'll see test questions like this. So you want to be familiar with this and look over Venn diagrams and the general addition rule in your book as well.